Good morning. Welcome to lecture 28 and 29 of, on thermodynamics of materials. So we are discussing assignment number 3. So let us continue with this assignment number 3. Number 3 continued. And you note this, your first class test, March 31st, 10 to 11 in the morning. Okay. So the problem 2 actually, we started talking, problem 2, let me write the problem, that will be helpful. Problem 1 was solved. Huh? Okay. You don't have difficulty sitting here? So problem 2 is this, the heat of combustion, or enthalpy of combustion of tungsten carbide which is very hard wear resistant material, tungsten carbide. Okay, so at 298 Kelvin is kilojoule per mole. Determine the standard heat of formation of tungsten carbide at the same temperature. What is this delta? What is the formation? Standard superscript 0 and formation WC temperature. This is a symbol given delta H0 WO3 tungsten trioxide 298 minus 832 kilojoule per mole, delta H0 CO2 298 is minus 394 kilojoule per mole, same. Yeah? So solve. Okay, solution here. Start this side. Solution. First of all, you have to write the combustion reaction. What is the combustion reaction? Have you solved this problem? Anyone? Solve this problem? Why not? Pardon me. This is difficult. It is the easiest of all. If they all 7 say 8 sets coming, this is the easiest problem. So imagine what is your status. Easiest of all assignments, not only this assignment. It is so easy that actually it cannot be considered as any practice problem, because it is so rudimentary. So now you will of course admit that you could not, but next thing is why you could not. A difficult question you could not has some justification, has some ground. Easiest, if you say, sir, 3 plus 5, we say, I thought I could not find out what it would be, sir. I thought sometimes I think 8, sometimes I think 7. Like that. You'll see at the end that it is like 7 plus 8, or 5 plus 2. WC, just write that out. This oxygen goes to, I will label at the end, W, go to this oxide, combustion gives the final oxide, maximum state of oxidation. It could be WO2, but WO2, it is given also, but you should note that. Carbon will be not CO, the highest state, CO2. This is the reason combustion, you can write yourself. Go to the highest state of oxidation. So this is both is that. So 3O2 and 2O2, 5O2, 5 by 2O2. Have you solved Deogon? You have solved Vidyut. You must be Somo. Solved. Easiest, huh? This is very easy. Mirjor, you have? Okay. This is the, so delta H is what? Always leveling is helpful. Always, huh? So delta H, since combustion, delta H1 is given to as how much? Is correct. Are you sure convinced with this combustion reaction? You know why it is, you are convinced? What criteria needs to be fulfilled about combustion reaction? The heat of combustion reaction, there is a criterion, right? You write this way. This is instructed there. So what is that? Have I satisfied that? What is that? The definition. You cannot read the notes also. What I discussed, heat of combustion, that class you are present. So why? You should be absent, you will not be studying, you will not make up. What is heat of, since this is combustion, what is heat of combustion? This is the technique. Don't take other steps. Yes, Vidyut, is it correct? What is the reason I have written correctly?
Combustion exponent reaction delta H would be negative and the temperature 298 Kelvin.
It can be any temperature. No, at a given temperature and, okay, 1 atmosphere, as a given temperature and pressure. No, that is not. Don't say too often 298 Kelvin. Okay? Data may be given for 298 is not usually tabulated. I said usually tabulated for now. What is the reason? I have correctly written. Yes, Amartya, is it correctly written? Is satisfying the definition of heat of combustion? Somo, Nirjor, have I satisfied the criterion of why? How? See how the answers is given. See, learn. Not from me, learn from your colleagues. That is the best way. Don't easily come to me, actually. Too often don't come to me. Ask first your friends. 1 mole, I underline always. 1 mole of the fuel. What is the fuel? That is reacting to oxygen. That is the fuel here. Not necessarily carbon. Anything oxidize. This component oxidize this. This is also fuel. It is playing the role of fuel. Was oxygen. CO itself is a fuel. C, not necessarily C, not necessarily hydrogen. That can burn with oxygen to produce oxidized product accompanied by heat evolution or rejection. So this is correct, right? At 1 mole. So delta H1 is how given as, unless reaction is not given, you have to write yourself, is minus how much? We are given to you, right? Minus 1195 kilojoule per mole. Per mole means what? Tell me, per mole. Tell me, per mole. Every quickly understand this. These easy, simple things. I will ask questions on this. Delta H1 is per mole is what? Is it customary to write per mole? What is per mole? Mole means whose mole? Whose mole? Per mole. You can always say per mole. Who? There are so many species. As we divide per mole of this tungsten, we have to write per mole of tungsten. But I am asking now, it is correct. Per mole formation. Per mole. 1 mole of the formed compound. See here, per mole means 1 mole of WO3. 1 mole. See, you will see, there are other species which are not 1 mole. But you should stick to this. Per mole of the, it is implied, per mole of the formed compound formation. Similarly here, per mole of the fuel. Fuel is WC. Okay, per mole, it is implied. The fuel. Right here, fuel and combustion. Fuel, happy, okay, good word. Now I'll ask, suppose per mole of oxygen is how much? Let us see, this will be answered by Amartya. Per mole tungsten carbide accepted. Very good, sir. So, sir, per mole of oxygen, if I ask, how much it will be? Same? Yes, good. Exactly. This is correct. Everyone remember. No. No, wrong. Into 5 by 2. Divided by 5 by 2. That is good as far as for 5 by 2 mole of oxygen. That's good. So for 1 mole, what would be? 5 by 2 to 1 means 2 5, 2 5. Okay. So note, if necessary, okay, is forever. This lesson is forever. Minus 1195 times for 5 by per mole, right? Per 5 by 2 mole of equivalent per 5 by 2 mole of, everyone agreeing? Is okay to? And per mole, then it will be per mole, that is minus 119, this extra lesson times per mole means 5 by 2 on into 2 by 5 kilojoule, right? Kilojoule here, kilojoule per mole. If I give this one, you can get back to this one. Remember, per mole of tungsten. If I ask you, per mole of this, then you have to get back to this. Remember, oxygen is not the fuel, but rather oxidant. So, addition in note is okay. Now start. What is delta now? What is delta each one? Is what? Delta each one is what? Heat of combustion. Enthalpy of combustion is what? Is also generally called heat of reaction. All reactions are heat of reaction. Two special types you have learned so far. What are they? Or formation one, combustion next. No problem. Heat of reaction. Okay, delta H one. So what is this by the way? By definition, reaction written in terms of formations. The formation data are available. How will you write? So write this formation right hand side, delta H WO3. Since temperature is 298, assign 298 plus delta H. Since the standard means 1 atmospheric pressure, nothing else. All are pure. 1 atmospheric temperature is not specification. No, don't ever say 298 is the standard temperature. 298 Kelvin is not at all any temperature. At what is standard state? Your substance at 1 atmospheric pressure and at the temperature of interest. So any, it can be 400, 500 Kelvin plus delta H0. What I will write? CO2. What I will write next? Devapam?
Minus delta H of
Delta H0 WC. Good. 298. Happy? And what else? Nothing. Only compound. This is not a compound. This is the constituent element. So it is automatically taken care of. If you expand this to you will get, say, what you will get in terms of absolute enthalpy. Absolute enthalpy all should be, it is as good as, recall this. If you have any confusion, note, additional note, additionally, then you will understand this is not directly, additionally note here, additionally note. Additionally note. Additionally note. Additional note. Okay. Additional note. Good. Additional note. Sorry. We are taking time. As a note, what you will note? That what I want to say. Yes. So I am showing you. What is delta H on other way? Other definition? Other definition is what? Enthalpy of product. In terms of enthalpy of product minus enthalpy of it. What are the enthalpy of product? Write that out. HWO3 298 plus HCO2 298 minus HWC 298. Do you drop O2 now? Will you drop A2? Now this time don't drop. Enthalpy, absolute enthalpy, that nothing to of the species. Okay, this is not formation, absolute minus. See, these two are equivalent. Remember, these two are equivalent. Why? How do you know this? I explained you. You can. How will you explain in terms of H? How will you explain this in terms of H? Who will answer? Huh? In terms of age, let us say Murmu. You must be Murmu too. Huh? In terms of age, break this. In terms of age, this is a formation. What is the reaction here? Huh? Example. Example. What is the formation reaction? You have to write the reaction. For WO3, what is the formation reaction? Is constituent elements and 1 mole of the compound formed WO3. What is this? 3 by 2. That's it. So what is delta H WO3? See, follow this. You can always break it in terms of individual species, not compound necessarily. Okay? WH is nothing but H in terms of absolute enthalpies of the participating species or reactants and product. What is this? The HWO3 minus H of, this is product minus reactant plus 3 by 2 HO2. I'll be very happy. What is this? That is a Devapam will try. Yes, Devapam, yes, Anurag will try. HWO3 is what? Do you accept this? This is okay. This is a formation reaction. I'm breaking this. This I'm breaking. It will automatically bring in this term. Okay, and plus this term. So automatically you will write for each term. You get back here. You get back here. Okay. If you break this like in this manner, this term and this term, you always get this. Okay. Oh, sorry. Here. Yeah. Break this into this. Break this into this, and break this into this. Yeah. Thank you so much. Thank you so much. Absolutely. So if you break this, you get this. So you're coming in terms of this. Similarly, break this. So now question, what is HWO3? What is H? I'm writing so many things, but I should know what I'm writing. What are they? Absolute enthalpy. Enthalpy. Okay, you don't have to use enthalpy. I'm not contrasting anything. Enthalpy of? Enthalpy of? HWO3 is what I'm asking. You have an answer. You should not ask back. Your answer should be enthalpy of WO3. No, not complete yet. 1 mole, molar, extensive intensity, go back. That's why I told you each introductory definitions are important. What is that? That's the extensive. This is molar. These are all intensive. Molar, 1 mole is there. 1 mole, moreover, if you assign temperature 290, add 298 Kelvin. And standard state, 1 atmospheric pressure. Non-standard. Currently, we are using all standard states. Okay. Then what is this HO2 again? This is also molar. That's why 3 by 2. Since 3 by 2 moles are involved, this is the reason. So all clear. And compatible, consistent, satisfied. So no problem. Okay. So these are additional talking. Okay. So leave it. Okay. Let us substitute these values quickly. What are given to you? I'm writing here. CO2 is given to you how much? Minus 394. What is this? Is the unknown. This is the unknown. And what is given here? This is also given to you as what? Minus 832. Okay. If you substitute this gives you. This leads to delta. You do yourself. I have done myself. 298K turns out as, you have got this value, I think every of you, I gave you the answer, minus 31 kilojoule per mole answer. That's it. Very satisfactorily we have completed this problem. Last day actually we are short of time, so we should have not started. This is a discussion. But still I'll ask. See, endless asking, endless questions and endless answer. Okay, let us try. What is your name, by the way? Simon. Sahid, what is this? Can you tell me what is this? This is what? What you find out finally? What is that guy? delta H0 WC 298. Nirjor, what is this? Tungsten standard, full standard heat of formation of tungsten carbide at 298 Kelvin. And pressure I don't mention because standard means 1 atmosphere. So pressure is redundant then. Mentioning pressure is redundant. Otherwise non-standard means 2 atmosphere is mentioned. Okay? That time symbol will be 0 will be dropped, delta is. But pressure is not so significant. Then what is, yes, what is this called? Yes, can continue. What is this? Formation. So for what reaction then? For what reaction this is this value, this delta H? You say formation, heat of formation. That means there is a reaction, I hope. There should be reaction. What is the reaction? That it represents 100%, 200%, correct. This I found. It is not given, not written formation. Ask you W plus C, WC. W solid plus carbon solid is WC solid. So formation, sir. Formation because why? Formation 1 mole of the compound. Constituent, I don't care. Means, reactants I don't care. Formation means product. Okay. Do you accept? So W plus C, this is just addition of W solid plus carbon solid is WC solid. Yes, Nirjor, since you are doing very good, the negative is correct. It should be so. W plus, this is the reaction to, okay, everyone agreeing to. This is the reaction that is represented. Is it negative? Did you expect? Or is wrong? How, did you expect or you didn't expect anything? It can be anything, sir. Negative, positive. Anyone? Did you expect negative? Anyone expected? You don't have any expectation? Anyone? Exothermic means negative. Negative means exothermic. That is okay. That is not a question. Did you expect? Why it is exothermic? Question is returned. Why it is exothermic? Why not endothermic?
So for the compound to form, it should be of energy should be released. So that is why it has to be of
combination, not necessarily formation. Yes, sorry. It's right. Formation, combination of the elements. Combination of the elements. Or sometimes also, any, in general, combination reactions. Combination reactions are exothermic combination. And this is, here you cannot say both ways actually are 2, okay. So normally actually combination reactions are exothermic, okay. Like, and formation reaction, obviously combination reaction. So no surprise, I am all satisfied, sir. Good. Here also, these are all negatives, oh, formation of this. What is the formation reaction here? Somo, what is the formation reaction? 3/2O2 is again combination should be negative and given negative. Which reaction is more exothermic? This or this, which will liberate more heat? 1 mole of tungsten, and yes, W. This one. Now this is this is WO3 will be more exothermic. Careful. So all related things actually we have understood. Okay. So this is 1 mole of carbon burning with oxygen. This is 1 mole of tungsten burning with oxygen. But the enthalpy change is greater in case of tungsten burning rather than instead of carbon burning. Okay, good. So problem over. Remove. So this discussion, remember this. Addition and discussion is very important. Okay. Just not solving the problem. You should be all careful. Problem. Next. Problem. I should say 3 is skipped. Problem 3 is writing. Problem 3 is withdrawn. Write somewhere. Problem 3 withdrawn. You can solve this, but I am withdrawing it. It is not withdrawn. Problem 4. Problem 4. Let us quickly write it out. It is a good idea to write the problem so that we have actually total view of the problem. Okay, quickly. Consider the 2 states. Consider thus two states. Now let us go faster. Two states of a reacting system. Okay, this also I will go slow. This I will go slow. Of a reacting system is of a reacting system and chemical reaction system. Okay. Given in figure 1, given in figure 1, given in figure 1, given in figure 1, okay. If 300 kilojoule of heat is withdrawn, is released, or as the system is released, as the system moves passes from state 1 to state 2. This is given to you only data. Determine delta U0. See, read how I am writing. 1000. Clearly for the reaction M solid plus half O2 gas is MO2, MO solid. Sorry, MO solid. This is the problem. Okay. Now see, this is what reaction. You can check what is the reaction. This is formation. This is a formation reaction. That is, since this is a formation reaction. So what is asked? Delta U0 1000 or to which way you can write? Since formation, first you write MO. First the form thing, and then the temperature. This is asked. This is to we found this. These are as good, same question. I could have asked this question. Find this. Not so much. Then you have to write extra load. You have to write formation reaction, which I have written for you, but I may not write. I just say delta U0 formation. What is the delta U0 is what? So more. This is what? What is the name of this? Complete name? Standard internal change. Standard internal energy of formation of MO. That is enthalpy of. This is internal energy. Heat. That is we call heat actually, and that's why I said always say enthalpy is better term than heat. Heat is sometimes equal to enthalpy, sometimes equal to enthalpy change, and at other condition it is equal to internal energy. One is constant pressure condition and constant volume condition. Constant pressure condition heat is equal to enthalpy change, and constant volume it is internal energy. But don't worry, this is asked. Let us see what the state 1 and state 2 as given. I am just drawing this part for you. Figure. Start. This is the constant pressure. P is 1 atmospheric pressure. So standard state pressure is shown here. This is a thermostated system. Reaction system. You remember. T is thermostat. 1000 K. You know this is a thermostat. You know very well. That is the surrounding. What are the taken stuff? 100 M. Solid, you understand? Solid, and 10 O2. Oh, sorry, give space here. 10 O2 gas. Initial state 1. What else it can be? State 1. Okay. This goes to the state 2. State 1 sometimes you can write initial state and final state. Okay. State 1 to state 2 is what? You draw similarly. What will happen? This will be come down a little bit. P is still standing there at 1 atmosphere. Thermostated condition is still on. Thermostat 1000 Kelvin, temperature state 2, but what it contains? 98 M, 902, 902 and 2MO. 2MO is the solid. As you right? Yes, I get that. It's solid. So you follow this solution. First of all, you see delta H. Acha, let me take this. Okay, it is better actually I go this way. Acha, overall, this is start this way. The overall process is better. I'm writing, follow me, state 1. What is the initial state? 100 M solid. Oh, solid. Plus 10 mole of O2 gas. Happy? What is these two things? Is moving to the next one, 98 M solid plus 9 O2 gas plus, tell me, plus right here 2MO solid. Since this reaction is carried out under constant pressure and temperature, so right here that applies to both sides and each species. Each species is right here. Instead of writing separately, right here means 1000 Kelvin, 1000 Kelvin, 1000 Kelvin, 1 atmosphere, 1 atmosphere, 1 atmosphere. This gas is 1 atmosphere. Okay, this is the overall reaction. Acha, then you follow me. This is, have you solved this problem, anyone? This problem? You couldn't? Huh? Could not? How far you have gone? Delta H0MO? Now you see. Acha, or see. Acha, you follow. See, I am writing, follow. See, this is 98. What are these? Unreacted. And how many moles of new thing? MO, 2 moles. And obviously you can guess, since 2 mole MO means how many is gone here? The reaction is actually M plus half O2. Means for 2 moles of MO, how many is gone? 2M and 1 O2. So 2M going out, disappearing means 98. And 1 O2 disappearing means 9. And 2 is the produced stuff. So no, sir, very good. In fact, that you write systematically. So 98 and 100, see they are under same temperature pressure, you can easily subtract and simplify. So no problem. And 9O2 likewise, just 1O2. Or, right, or is, right again, 1000 Kelvin and 1 atmosphere, 2MO solid. This is the overall reaction. This is the overall, call it 1. So instead of this, same sir. Okay. What is this? Delta H1 is what? Delta H1, okay. Delta H1 is what? Under constant pressure is QP, and constant pressure. It's a constant pressure process, right? Constant, right here additionally, or you drop this P then, constant pressure. Is how much it is? Given to you. It is given to you. Released. This heat is released. Where? Released where? Is released to whom? Thermostat. Unless it is released, then its temperature will rise. Okay? So, but thermostat is temperature should rise, but thermostat is very huge stuff. So this you know, like atmosphere, so big its temperature never changes. This is accepted. This is a thermostat or temperature controller. If it is a electrical, okay, that system. Okay, open reactor, temperature furnace temperature controller. That is a device for maintaining temperature. Okay, by relay, turn off on to maintain temperature. So this is thermostated device. Very good, sir. So delta is how much it is given? 1000 is what given to this system rejecting. Okay, is released means what? Plus or minus? minus x kilojoule. Okay, this is the one delta H one. Okay,
300.
300. 1000. How I got? 1000 is the temperature. Thank you very much. 3000. So delta H one. Okay, very good. This part is okay. Now, is it formation? Is it formation reaction? This is what I got. A formation is, as you know, you should know, M plus 1 mole of the compound. 1 mole. So it is half of this. Half. It twice the formation. This is the twice the formation. So formation reaction, I'm coming at the end. Formation stuff I'll take up. First, your aim is to go to delta E. Okay. Shall I write delta H0? Okay. Since can I write this delta H01? Will you mind? You will never mind. Will mind. Why? Why not? Delta H1 is because standard state. Temperature is not, no problem. This is pure. So this is, as I'm writing for you, is also same as delta H1 in this case. In this case, superscript 0 is the standard state. And standard why? Pure. Every is pure and 1 nanosecond. Very good, very good. See, each one is a follow. If you want to know, this is a very good example why you can see 1 nanosecond applies to whom? All of them. What the metal is exposed to 1. Oxygen gas also 1 atmosphere, otherwise it would expand. So gas is also 1 atmosphere, metal is 1 atmosphere, like this. This share is exposed to what pressure? This pressure, 1 atmosphere. I am also. This gas is also 1 atmosphere. So these are the things, okay? So similarly here all 1 atmosphere, 1 atmosphere, this pressure. So no surprise, this, okay? But anyway, very good. Then what? And now I'm writing delta 0. Now your interest to go to delta U0. See, follow the question. Delta H0 1 2, you will move to delta U0 1 plus what? Plus what? H is U plus PV. Recall, H is U plus PV. When you apply to a reaction, it is delta product minus reactant. H is U plus P for any single species. But when the reactants and products, it is delta. So delta of this is delta of the reaction plus of this process plus delta PV standard state. Okay, happy? So this is the one that you will find. If you find this, then you will be find just formation will be half as much. Will be half and so find this. That is the problem. What temperature you can write? You know what temperature this is talking about. Will you write this or at the end you will write? Acha. What is this? Tell me. Delta H01 is how much? Right? Minus 300. Okay, kilojoule, right? Kilojoule, no problem. Is delta U01. What is delta?
We have to take, since it is a formation reaction, for the formation reaction we have to multiply with half.
Later, at the end we'll do. I have not done that. I'm not taking up that. I'm finding for which reaction? 1. At the end I'll divide by any time I can do. That I'll do. You can do here also. At the beginning you can do, at the end you can do. Challenge is, I don't like this. Delta H, and you cannot actually know what you have missed, actually you should make up later. Delta H and delta, how to get delta U from delta H, that is the, if any challenges, there two things are important in this problem. To know that it is delta H for this reaction, this is reduced to this, and delta H, that is from Q, this is 1, then delta H to delta U. For this reaction, any stoichiometry you know, then you can go to this stoichiometry. So stoichiometry is not a factor of, okay, by factor multiplication or division. So delta PV0, P is the constant here, P. Because same constant, delta V0. What is this? I am writing another step for you. P is what? 1 atmosphere. I write at the end. What is the delta V0? Reaction. This delta reaction. Delta for reaction. So delta is product minus reactant. What is the product? Right here. 2 V0. This is the change. 2 V0 MO. What is the implication? V0 MO is molar. So 2 moles are there. 2 moles are there. 2 moles times molar minus V0, 2 V0 M plus 2 V0 O2, and you must give a bracket completed. 2 V0 O2. Happy? Okay. Then continue delta Now these two are what? V0 molar volume as compared to oxygen volume. These are solids. Solids, remember? Note V0 MO solid and V0 M is what? Molar volume, 1 mole. What I taught you is much less than V0 oxygen gas. Did you not remember? Molar volume of solids are always much less. Huh?
not M minus 2 V not M plus V not 2.
My 2 V0 M plus V0 O2. Thank you. V0 O2. Yes, thank you very much. Plus V0 O2 is okay. Is that right? Eto. Delta V0, see, delta V0 is what? This reaction 2 V0 MO minus reactant 2 V0 M plus V0 is okay. Now it's okay. So now V0 M, V0, they are in plus or minus, they are negligible compared to V0 O2. So even if their minus means even less, they are already very small and their difference is even less. In any case, we don't care. So this approximation we will do is what? P V0 O2. What is this? Continue. What is PV? P volume, PV gas, nRT. nRT. There are many ways. Minus. Thank you very much. Minus P. What is this? nRT. Thank you so much. PV is nRT. Happy? PV0O2 is nRT. O2 is a gas. PV for a gas means ideal gas. PV, nRT. Okay. Or you can do one thing. The same result. nRT will get back. How? You know, so you are not touch this. P is okay. P 1 nanosphere. P is what? 1 nanosphere. V02 is what? Volume of oxygen at 1 nanosphere. What is the volume of oxygen at 1 nanosphere? Try separately. What is the volume of oxygen at 1 nanosphere? At the temperature of interest, at temperature, say T, here I have considered. T means, you know, T is like 1000 Kelvin actually. T I am writing. What is that? Suppose you separately take up. What is the molar volume? V is, again, go back to the ideal gas. nRT by, tell me, nRT by P. You know actually, for example, one value you know. 1 mole volume, molar volume of oxygen or say ideal gas at temperature is 273 Kelvin and 1 atmosphere is how many? 22.4. That is a standard, but better you go by this. You know how will you get 22.4 liters figure? Let us see. How many of you know 22.4 liter? How will you get back here? Can anyone show me? You can show me? High school. Now, no, nothing. You give me 1 mole, 1 gram mole, volume is 22.4 liter. Can you show me here? From here? 1 gram mole is a special case. So, in any case, you will use this. I don't like this. I hate this thing. I've put a question. See, why are we discussing? I'm addressing individually. How do you get 22.4 liters from here? How do you get 22.4 liters? Who said you that 22? How do you accept that? And then, why one? Why? Because that is the 1 mole, sir. If it 2 moles, it will 22.4 times 2. That is the okay 1 and pressure. That is the standard. That is given. So here, you will easily see. You will get immediately. You will get 22.4 liter the figure. So for that means anything you can do. So nRT by P. You multiply here. P times nRT by P. Follow. P times nRT by P is what? nRT back. Have I written anything wrong? Convinced though? Starting though. So what I did, follow again. Solids are removed. If solid values are given, you put that. If not given, neglect compared to the volume of gas. Example, you know, I told you one good example, 22.4 liters, just for reference against water. 1 mole, how much? 1 mole water volume is how much? 18 cc. Gram density is 1 gram per cc. 18 cc against 22.4 liter. Imagine. Can you imagine what is 10 How many cc? 22.4 liter. Your name is a moment ago. What is the name? Said. What is how many cc? In 22.4 liter, how many cc are there? 22.4, 1 liter is hard, 1 liter oil, 1 liter milk. So 22.4 liter contains how many cc? 1 liter contains how many cc? You don't know? 1000 cc. So it is 22,400 cc against 18 cc. So be convinced. How many times you remember and take it granted, accepted? Happy? So you see, either way, PBG is what? Inactive back. It is totally up to you. Totally up to you. So shall I proceed? So delta U0, as he has correctly said, I am writing for you. N is how many? 1 mole. 1 mole, this is okay. This is molar 1 mole. R is how? 0.0. R what shall I write? R what shall I write? Yes, what value of R I will write? Barakpur local. Oh, yeah, you didn't get time to know the value of R. 8.314. Yeah, 8.3. You can write 0.082 liter, but that is equal to 8.314 joule, because this is in joule. This is in kilojoule means joule. So 8.314, right? 8. Thank you very much. Times temperature is how much? 1000. That's it quickly. So star and give the answer. Shall I remove this whole stuff? This is no longer required. So this is required. So what is this? I am writing delta. This is the one. Delta star. Delta U0. So delta U01 is what? Tell me. What is this? Minus 300. Sorry. Minus 300 kilojoule. This is how much? 8.3000. This is joule, remember, this is joule. Okay? Joule per mole. Okay, you know, joule. So 8.314. What is this? Suddenly I jumped into this. Why? Okay, minus 300 this side. And this will be goes to the other side. 8.314 joule. Kilojoule. You know, this is joule, 1000 kilojoule. So what it is? Minus 8, you consider 298 kilojoule. So it's okay with you? Remember this is joule, this is by times 1000. Is okay? See joule, and you want to kilojoule divided by 1000. This is joule. So you don't understand this? This is I am writing unit writing. Joule per mole per Kelvin, per Kelvin. Units, follow the unit. What is this unit? Kelvin. What is this unit? One is what? Mole. So what you get out of this? Mole cancel, Kelvin cancel. What remains? Joule. Joule to 6 kilojoule divided by 1000. What you will get? 8.34 itself. Okay. So minus 298 kilojoule. Happy? What are you doing? Just concentrate here. Is it per mole? Yeah, you are restless. You are getting restless. Tell me. It is per mole too. What I'll write? Kilojoule per. What should I write? Whom I ask actually, then I will ask you. Okay, I will give a fresh question, or even this question will be passed on to you. For how? What is kilojoule for what? For this reaction, obviously. For this reaction, first of all, one means for this reaction. Now look at. You have to look at this. Per kilojoule, about this, how many moles are here? In terms of MO is important. Per. That's it. See clear? Which is one? This reaction. Per 2 moles. Or per 1 mole of oxygen is as good. So, but since, okay, per 2 mole of MO, you can write that. So, what is the formation reaction? What is this? Can I remove this? And remove this? Remove this? Remove this? Remove this? Remove. So, what I said then, hence, delta U0 Okay, this is what reaction this is right here. 2M plus O2 is 2MO. Hence for the reaction M plus half O2 is MO, which is the formation reaction. You can come in, okay? You want to come in or you want to stay there? For what? So ask me whether you get in or huh? I'm always teaching. 2M M plus R2 is MO. Okay, M solid, half O2 is gas. You can write this. This is the Gibbs reaction or formation, whichever you call. Is how much? This is against 2 against 1. How much is delta? Good boy. Delta U0. Delta U0 for this reaction is what? Extensive, intensive. Second day or first day's lecture. Extensive, always. Every moment, every breath, extensive, intensive. Remember these words. Extensive, intensive, every breath. So, 292 divided by 2 minus kilojoule per mole. If you must specify, you may specify per mole of MO. MO is the series. You specify one species, others are automatically taken care of because one mole MO means 1 mole M. Half mole to any you can write for the reactions. But any compound, since the formation compound is actually customarily we write for compound. Okay, answer. So the main thing I tell you what is the intellectual part of this? I tell you. See, suddenly you will be confused when it is asked delta U. I am giving you the secret. Delta U is given just for trick. You should not at all look at. You should look at what you get. Delta U is the internal energy. Heat is equal to this heat. 300 is not equal to internal energy. Is not equal to internal energy change under this condition of constant pressure. It would be equal to internal energy change, internal energy change under constant volume. So what is equal to heat is equal to this heat is equal to delta H. So first of all, I will solve this problem as if delta H 0,000 is asked. Take up this problem. Then at the end, delta H to delta U is nothing but delta H is delta U plus delta PV. And all set. This is how it's managed. So first of all, you see, since constant pressure, heat is equal to delta H. 1. Then what else I said, okay? And standard state also you got it. So I explained everything. Careful, one problem you solve many problems, okay? This is actually, this TV5 is a class of problems, this thing, okay? Good. Can I remove this? Problem next. Remove this. Very good. Can I remove this? This one? Top? Not required anymore. All clear. Full clear. Next is problem, a big issue. Typical thermochemistry problem. Thermochemistry, or if you like thermometallurgy. Typical. Hardcore metallurgical problem. Problem 4. So let us write it first. Okay? That is, you have to answer. I will often ask questions. It should be on your guard. Who came? Oh, it is a time, na? Your 1 hour later. Do you know it is a 2-period class? 11, it is already 11. Huh? 11? Now first to have the. Now you can easily think that 11 class means 10, 12 is 1. So every time you will come 1 hour late and see the class is over. No problem. And you will be exempted. No, sir. Okay. Problem 4 is, okay, an adiabatic vessel. See, often adiabatic, the word comes. Adiabatic, isothermal. See, and adiabatic. Yes, only 2 problems. Thank. 47 minutes. An adiabatic vessel contains 1000 I don't like this. I don't like this. No. I don't like this. Okay, keep quiet, right? Or if you have the problem, no problem. Okay, okay. You think about it. I soon ask the question. It's better you prepare then. If you have got the problem, have you solved the problem? So then I will ask you the question. The moment I complete writing, I will ask you a question. Then you'll be at sea. You do not know what to do with that. So better you concentrate on this problem rather than what are you talking with him? You can talk actually for years with him. All stupid things you are talking here. You have not prepared yourself, even by first class you are not prepared. Contains 1000 gram of liquid aluminum, no interest. Okay, see, you know, of liquid is better I write from here, huh? Of liquid aluminum, quickly, aluminum, at 700 degrees centigrade. Mark everything here, 700 centigrade. Calculate the mass of Cr2O3 solid, mass of chromium oxide. Let me write first Cr2 solid, which when added to the liquid aluminum, which when added to the liquid aluminum, what will happen? With which it reacts, it is given to you for assistance, with which, for help, actually for hints, with which it reacts to form chromium and alumina. Chromium and alumina. And alumina. Happy? Happy? Huh. This in bracket raises the temperature of the resulting mixture of alumina solid, chromium solid, okay, and chromium oxide solid, 2000 degree centigrade. Happy? The initial temperature of the added chromium the chromium oxide rather, is 25 degree centigrade. Given the data, this data is useful. Cp alumina, will be write very important. This data, as I told you, heat capacity is an important thermodynamic data. 106.6 plus 70, A plus Bt, recall A plus Bt plus C T to the power minus 2 is the general form of heat capacity. I gave you 17.8 times 10 to the power minus 3T. Quickly, this minus 28.5 times 10 to the power 5 T to the power minus 2 joule. Unit is per degree, mean degree Kelvin, mole. Okay, goodbye. Cp, another one, chromium. Cp chromium solid is what? 24.4 plus same format, A plus Bt plus C 2 to the power minus 10 to the power C minus same unit, and last is Cp of what is alumina. Alumina solid. So what? Cp of alumina already no? Chromium solid, Cr2O3. Already 119.4 plus 9.2 times 10 to the power minus 3T minus 15.6 times 10 to the power 5 T power minus 2 joule per degree per mole, and also given enthalpy. You try to read it well. You know, you can read, you are smart now. What is this? Delta H0, L23. What is this? What is this? What is the name? Name, you think about the name, I'll ask you, let me write the value, minus a huge value, 1676. Tell me what is this stuff? Joule per mole. Mole you can write MOL or MOLE. Delta, oh, delta H, another heat of formation, sorry, I'm very sorry, is what? Again, the temperature is given as what? 973 is 120 300 joule per mole. Again. What else? Atomic weight, you know. Atomic weights. Atomic weights, right? Since given atomic weights, aluminum, you know, everyone knows 27, and you know, oxygen, you know, chromium, you know, at least. I mean, also, you know, chromium. What are you doing? What are you asking? Concentrate here. Chromium is what? 52. Oxygen is 18 or 16. You know, note that. Oxygen is 16. I'm not writing that. T melting aluminum. TM aluminum is what? I told you, very easy to remember, 666. 666. Melting point of aluminum. That is 933. That's a 9, I'm writing, 933 Kelvin. 933 Kelvin. Is it? It is 660, no? 660? 660, I'm sorry. 660, 660. 660, right? 933. Over. To find what? Find here. Question is here given. Calculate. So, let us follow this. This is okay. Make a barrier. Please. What is this? What is given? What is it? Formation. See, alumina written means formation. Delta H and alumina. Formation of alumina. That you know. What is the reaction? You know. Formation reaction for alumina. That you will do. And likewise this. Okay. For this, these are all CPs. Nothing else. Melting point is 933. That is 660 degrees centigrade. What has her? So what is this? Now tell me one thing. So I tell you the story. This is a story. Adiabatic system story. Chemical reaction story. A chemical reaction occurring in an adiabatic reactor. Okay. So what is this? Liquid. I wonder, you have some liquid aluminum in a reactor. Say, just I will remove this because say liquid aluminum liquid. Forget this 700 degree centigrade means 973 Kelvin, and you are charging it is adiabatic. You have also charged. Suppose it is you have charged. What is the charge? Yes, Cr2O3. Cr2O3 plus Cr2O3 solid. What temperature? They are entering at 25 degree. See, follow this. 298 Kelvin. Follow the question I am asking. So these are the one liquid 973 is liquid aluminum. Liquid do you expect? Yes, above the melting point. So it is liquid, no surprise. It is 933, it is 973, 700 degrees centigrade to 973. So should be molten, so it is good, makes sense, sir. And also these you have added and then made it adiabatic or just adiabatic and then added and again adiabatic. It's adiabatic. Question is, how sir 970 liquid if I add a solid, cold solid, room temperature solid, how the temperature can ever be raises, temperature raises as I add temperature resulting mixture raises the temperature to 1000 degrees centigrade. 2000 raises the temperature to 1000 degrees centigrade. How can it be raised? We know what? I have a cold body, hot body, the temperature will be somewhere between them. Like first problem. Liquid aluminum was hotter and water was colder. So they enter in a T prime, which is T1 was T, another is 298. Somewhere T prime will be somewhere. between them. Okay, this you know. So why it increases? How it will increase ever? Rather than between 973 and 298, I should say. Any answer? Adiabatic. No, so you cannot say actually. No heat is given to this. Latent heat of solidification. Full solidification. These are latent solidification, then the heat will be okay. Sorry, but you have to give the heat. Solid. Okay, you have to this. Okay, huh? So it will solid, but you don't have aluminum solid at the end. Now appreciate the problem. This is the idea that why you come? We are already 1 hour over. You go back and read the routine and let me know. I'll ask you about the routine first. You read your routine. And go. No, you first go read the routine and then let me know when this class was scheduled to start. You answer this question. This is not difficult question.
Sir, sorry, sir. I didn't get it, sir. Because I'm still understanding. I thought class started now.
You should, what first semester means what? You don't waste my time, okay?
Sir, sorry, sir. I didn't.
Now you say, wait. For sorry, you should be okay there.
Sir, please,
So
sir.
5 minutes outside, at least 5 minutes. Some penalty is there. Everyone is doing this. 5 minutes outside. See, 5 minutes and then. Okay, happy? Okay, this one. Question. So why? Can anyone explain why this happens?
Reaction.
Chemical reaction. These whole thermodynamics we are studying to handle chemical reactions. So chemical reaction, you will actually deal with actually okay, numerous chemical reaction problem. So chemical reaction is what then? Yes, accepted. Chemical reaction, very good answer. So what temperature rise? Why? Yes, since you have answered, why will rise?
Aluminum and chromium oxide will react then with the formation of products.
It is an exothermic reaction. So the reaction we are talking is a mass than exothermic reaction. Otherwise, this problem can't be. This is the answer. So appreciate the problem. Come on in. Come on in. Hello. So this is the you check with your routine, huh? Routine. No. You will check with your routine. Like what time it started. Then you will understand. So what is the next thing that now? First thing, understand the problem. Don't jump into writing this thing. Oh, how? So start. Now I will. So you have understood the problem, though. So there will be reaction. Now how to solve these problems? Now solution. Now solution this way. First of all, do some preliminary things. So in terms of moles, what you have added here? 1,000 gram aluminum. Just complete this. 1,000 gram aluminum means how many moles? 1,000 by, you have done it. Who has done this? 37 is correct answer. 37 mole aluminum. Happy though? Okay. Anything else? You don't need perhaps, mass or mass ratio. This has been asked. Okay. So this is. Then another thing you see, reaction can occur at any temperature. So overall reaction, can I write? Please, let us write down the overall reaction. I am writing for you. Follow. The overall process. The overall reaction or process as I write actually. Sorry, this is actually getting. So let us do. Overall reaction is what? What is this? Right. Now, overall reaction I am writing. Input, output, then breakup. What is the input? Write nicely. What you added? 37 mole of aluminum. What temperature? Right temperature. And I told you condensed pressure, you can consider constant pressure process that 973 Kelvin. Okay, 973 Kelvin. Okay, or 973 in short. Plus what you added? Okay, what CR23. What you call this as N moles. So you have to write somewhere, na? Right here. Suppose N moles of CR23 added. This is to be found. N is to be found. CR23 solid to be added. So question is to find n objective. Moles, then mass no problem, mole to mass easy. So you write plus n moles of Cr2O3 that I have added solid. What temperature? 298 Kelvin. Okay. They goes into what is the overall process? You write in the here so that you understand what is the process. What is the process? Acha, you think about this. I will write what? I am writing the product. Acha, for product I am giving guidelines. This you will follow. There is a reaction about reaction aluminum plus okay guideline. You can write guideline aluminum 1 mole plus chromium oxide. They react forming what? You guess forming what? Given there also. Al2O3, this exchange reaction type plus chromium 2Cr. Happy? Now you will actually write in terms of, it is wrong? 12. Thank you so much. Now you write in terms of 37 moles of aluminum. Best, I can write there, I can write here for preparation in terms of 37 moles, what it will be. So 37 by 2 you multiply. So, or 37 aluminum, 37 aluminum that will remember this is giving plus right 37 by 2 Cr2O3. Write this will be helpful. Is 37 by 2 Cl2O3 plus equal sign I will give you here. Equal sign is here, guidelines here. Al2O3 plus what? 37 chromium. This is now this right. What you have got here? Tell me. Is this goes to right here? It goes to what? What you got? 37 aluminum reacts with 37 by what is the product? Tell me. How many alumina is produced? 37 by 2. Write nicely. 37 by 2 alumina. What temperature? See, I am following the problem. I am not writing. See, alumina moles I am giving and what it has said I am writing. What temperature? So 1273. No problem. Write nicely. What else? Another thing you can write. What is the product here? Chromium. 37 chromium. 37 alumina will be fully exhausted actually. And this have another. Okay. So plus 37 chromium. What temperature? Same temperature. You can write here solid. It is better you can write. These are all solid. High melting. Chromium is a high melting metal. And alumina is a ceramic. High melting. So they are not molten. So they are also given also to you. Solid. Your melting point is way above. 1000 degrees centigrade will not melt it. The alumina melting point is close to 1800 degrees. So likewise, chromium melting point is high. Okay, so 1400, 1500. So these two over, then what remains? So reaction product you have written. Aluminum is fully consumed stoichiometrically, is fully out. So what then 37 by 2 chromium has been removed. So what remains? How many chromium oxide? N minus. Good. Plus this is the overall. N minus right here from 37 by 2 has participated already, and remaining this is Cr2O3 and temperature. What temperature I write? Same. All in the adiabatic container. The same temperature. Once you have written this nicely, then you are all set. This I wanted to tell. If you can write this, then you break up. Breakup is 2 types of breakup. 2-step breakup. No, not 3. Not as broadly speaking, 2-step. What are the 2 steps? 2 kinds breakup. One is same temperature chemical. First of all, chemical reaction. Another is heating. Chemical reaction, heating. Chemical reaction will occur at same temperature, given temperature, constant temperature, and heating is from one temperature to these 2 steps. You remember for breakup. Breaking up is essential. So here, why will break up? Why will break up? Tell me why. One, this see temperature different. So handle this same temperature, but there will be another steps though. So I tell you what, which temperature you will consider this reaction has occurred. This reaction, see, this is the reaction. Box this. Which temperature you will consider? There are so many temperatures are around. Which temperature you consider? Any. You have to break up and then add back the steps to get the overall. what is the overall reaction? Give a name to this. It should be overall 1. I hope this should be given a name to this overall, name or no name. Okay, don't worry. So you have to, so break up anyhow, but which will be convenient for you, I tell you. See the data. Which temperature breakup will be a chemical reaction, which temperature? Because formations are 973. 973 is actually, so let us do this, means 700 degree centigrade. So let us take up this thing one, okay, and 73. So let us do one thing. So what we will do, I am writing breakup. So you are intending for the reaction to occur at what is the temperature? 973. Here already 973. That one is 973 already. The other should be taken, means yes, follow. 973, it must be taken to 973. Okay? And this will be auto, so that I will consider. So first of all, 37 by 2 Cr2O3, solid which temperature currently? You follow this step. Step 1, breakup, is 37 by 2 Cr2O3, solid back, which temperature? That particular, which temperature? 973. Follow this. This I am considering. I will show you at the end that this addition will produce the overall. Second step is what? Yes, now the reaction. See, this is 973 and this is 973, and this will be produced at, since what temperatures you have to consider? Produce, since chemical reaction will consider same temperature. So you consider what I write, that will consider. What is that? I am writing, follow me. So I am writing, what is this, sir? Aluminum, right? What is this? 37 aluminum. Liquid, right? Liquid. Give this. Don't hesitate. What temperature? 973. Let's see, I'll see every class. This gentleman called 37 by 2. This I am writing in fact for 973. You write yourself. Chemical reaction, if you want to use as a step, same temperature. What is this? What is the producing? Tell me, see here. 37 by 2. Tell me. Alumina, solid. What temperature? Oh, right temperature, right temperature here. 973. This is also 973 plus what? 37 chromium 97. Okay, make a room here. Plus 37 chromium, solid for your appreciation. Okay, you write. By all means write 973. All 9. So it is here now all set. All 973, sir. I can use heat of reaction concept at a given temperature. That I will use at the end. But let the breakup be complete. Or next, what will do? Guess. See your eyes here. Okay, eyes here. So they are not 973 finally. What is it? 1273. So take this up to 1273. Take this up to 1273. And this gentleman, I have only used 37 by 2, but it is should be 37. So what is it? 37 by I have used, what starting is what? Oh, I am sorry. This is n minus 37 by 2 is still to be addressed. So that I will consider at the end. That will be taken for 298 to these 3 steps. Total 5 steps. Repeat. You follow me with me. First thing you have seen, I have written for purposely. Why purpose? Data also, any temperature, see, principle follow, any temperature I can do. Let's say 800 I consider. Say 970,000 I will consider. But what is it then? Problem is nothing, sir. I can, in principle, these data is for 973 and 973. You can argue. So I can do 1000 also. How? 1000. Sir, this data is this. I can convert this data into 1000. Can anyone answer me this question? 1000, since I wish, Thermochemistry is the place where you can fulfill your, all your thinking, thoughts and actually see imaginations and inventions. Reinvent thermodynamics. You reinvent this subject. So 1000, sir, arbitrarily. Sir, no fixed method. That you should appreciate. 1000, so suppose 1000 I have used instead of 973, just this, 975 I have used. 1025 I have used. Then how shall I, but then data must be given. This data is for 973. Suppose I want for 1000, what shall I do? Can anyone? Then also you will answer. They say, yes, no problem for me, sir. 1000 I get the data. Since one temperature is given, I can get for any temperature. What is that? Yes, louder. Modified is just a Kharkov. One temperature, phase transformation has not taken. This gentleman is solid, and 1000 is also alumina solid. So easiest, he is correct. He has hit the right place, okay? A bullseye. That is Char Kharkovs. Use Kharkov's equation. So I will generate data. For this which need the relevant delta Cp. No? Delta is T2 is delta is T1. But I am talking actually, I am explaining everything so that your mind is free. Where mind is without, okay, fear, and mind is free, okay, free. So no comparisons are free. So, but anyway, now get back to the reality. This data, later. Next class. No, not allowed anymore. Okay, next class. 973. So you do one thing, what you will do? Okay, third is what? Now, so as I told you, 2 step down. So see your point. See, you reconcile with the overall. So this and this, I'm writing for you. 37/2 alumina solid, 973 goes to what? Step by step. 37/2 alumina. Which temperature? Tell me. Which temperature? 1273. Okay. 1273 1000 degree. Okay. Happy. Fourth step is what? Likewise, tell me. Fourth step. 37 chromium na standing there. 37 chromium. Sorry, what temperature? Acha, I'm see. What I wrote here. Actually, I am follow this. These two. This you got, but this is not the final step. Final up this. So these must be taken to this. These must be taken to this. One I have done. The second is what? That's why. So don't make mistake. 37 chromium, solid 973 to 37 chromium, solid. You assign this to what you see in the top 1270. These two are same. These two are the same temperature. Fifth is what? Last you have to be careful, because why careful? What was starting Cr23? How many? N. How much you have taken? Consider 37/2 for stoichiometry requirement. So N minus 37/2 is still pending. But address this left hand side. So N minus, answer this question. I will be very happy. Someone has to answer. I'll ask someone. Solid, follow. I'm helping you. So left hand side, see N mole Cr23. So N moles and N minus 37/2 plus 37/2 is N back. Sir, happy, very happy. What temperature? 298. Right hand side only your job. The question is you answer what shall I write? Right hand side. Somo will be able to write. What shall I write? See the overall. Automatically see well guided by the overall. Left hand side is okay though. Left hand side is N addressed. 298 addressed. Right hand side is what? What is missing? Right? See, matching? N minus 37/2 matching. Okay, N minus 37/2. Tell me, you carry on. Carry on. Carry on. What is this? 1273 from 29. Solid you add 1273. Thank you very much. You all said. What should I say? You all said. Of this again I tell you, follow me. Only one step is reaction. Which step is chemical reaction here? Only one step. Only. Yeah, chemical. I'm writing you, write that. Chemical reaction. And others are merely temperature changing. Same moles, same stuff, good stuff. Same. Chemical reaction is same. No, product is different than reactant, etc. Same. Heating, sir. Heating. This other step. So step 2, chemical reaction. And other steps. Namely, other steps are, tell me what type? Heating type. Constant pressure heating type. Is a constant pressure process as constant pressure heating type. This will help you to solve any problem in life, not your exam only. In life, oh sir, breakup is nothing. Then you say nothing is there. It looks big actually. Now what I'll do? Solve the problem. Can I? I think you don't need this. No? You know this. Is already given there, so I'm removing this. So I am making room this. Okay. So I'm just removing the whole problem, because problem is already written in terms of equations. is all written. So I'm removing the problem, solution, continued. So I give it this star from here to here. Solve one by one. Quickly. What is, now first of all tell me delta H1 overall. Delta H1 is follow. Delta H1 is follow. Overall. Are you convinced though? This will added return overall? Are you convinced though? Are you convinced? If you add this, you will not get overall. Shall I show you? See, I am showing you. The right hand side, cancel. See, and then what else? Okay, right hand side can cancel, and then it remains 37 by 2. What is the overall? 37 by chromium solid, and this will make n minus 37. This left hand side. Then what cancels further? I see. See, this one taken from 293. So don't cancel, just double it. Double. This will be add. You can add, left hand side, right hand side. This will cancel. Same thing, right hand side, left hand side. So cancel. So these are all off. What remains you will see 37 by 2 minus n 37 by 2 gives you 10. Chromium 298 all set. What remains are 37 plus left hand side is what? 37 moles of aluminum. See, aluminum left hand side. The others are removed. Right hand side. Clearly see what is this? 37 by 2 chromium 90. This also has cancelled. No, this is address where 37 by 2 chromium 973 to what is I'm giving this. So you see this where is 37 chromium. Achha, check this 37 chromium solid. 37 chromium solid is okay, matching. 37 by no. See, this has cancelled already. Yeah, this is this. You can check easily. This is this, and what is 1273 alumina? Where it is 1273 alumina. These two term, all things. So what remains here? Achha, what happens to this? This also tell me. This one, 37 by 2 chromium is where? See, right hand side, and this is left hand side. Reaction. For making preparation for reaction, preparatory to reaction, heating to 973 reaction temperature. So this, you understand, this is so easy. It is actually below secondary level of school. Okay, delta H1 is what? You answer this rather. Is what? Q. P I am writing, constant pressure. QP, constant pressure device. Adiabatic condensed phase can be considered as constant pressure process. Constant phase is what? Is how much? How much is? Q is how much? Adiabatic. Whole thing is adiabatic in an adiabatic condition. So what it is this? Same adiabatic flame temperature, same principle. Delta H is Q. So that what I try to arrive at, delta H1 of the overall is what? Okay, good boy. So it's 0. Okay, right? For adiabatic. This is a constant pressure. Condensed phase reactions, condensed phases can be treated in a constant pressure device. Okay, easy. Okay, okay. So constant pressure. Okay, see, only condensed phase, not gas phase. Gas phase can be constant pressure, constant volume. Condensed phase, constant pressure conveniently, but constant volume can be done also. But not much change because condensed phase effect of pressure is very small anyway. Okay, if pressure changes even, then effect is small. So constant pressure and constant volume is not given there, but you will understand. Imply that it is a constant pressure process. Okay, so no gas phase involvement. So exposed to the pressure of the system. Okay, constant pressure. Deep. Now what is then? Now tell me what is delta H1? Now you do yourself. What is done? These 5 steps added. So write this nicely. Now delta H1 is nothing but delta H. I'll write at the end. Write at the end 5. That these are 5. More importantly, quickly, very quickly. Delta H1. Start. Delta H1 is what? Tell me. See delta H1. See. You see. You participate. Then write. Heating. Pure heating means CPDT. Constant pressure. CPDT. So N CPDT. N is how many? 37 by 2. Good boy. CP. Cr2O3 dt. What temperature to what temperature? Tell me. 298 to 973. What is the CP? I have to write this for you. Don't worry. I'll take the trouble of writing everything. If students should follow the 37 by 2 heating. Okay. Delta H1 is what? Cp is what? 100, tell me. 119.4. Tell me. Plus 9.2. You don't have the data? A moment ago I have written there. I have already written. Is okay? Oh, okay, very good. You please check. Minus 15.6 times 10 to the 5 dt. You have got this? You calculate this. One exercise you do. Just one first. Then many you can do yourself.
All the terms, or you can eliminate.
All the terms?
So we need to keep the three terms, or we can eliminate one.
Why?
Why is it?
Eliminate. Why?
Because so a raised to power minus 5.
So 5 plus 5. Now even so, actually this is t to the minus 2. You can, but don't be over smart. From the very beginning, don't be over smart. Smartness later. That will actually, that will fit. That will justify. But from the very beginning, that's actually see your beginning student, like a novice. Okay. So what is this? I'm doing 37/2. Integration dt. Now it is math into the domain of math. Hot temperature to hot temperature. This is yes. You say Murmu. Hot temperature to hot temperature. 673. So first term integration dt. Sorry. Very sorry. Quickly. Let us take cool down. 100 first term follow. Integration dt means t and limit between limits is difference. So 119.4. Let me copy down. It will be easy quickly. Unnecessary 675. You check this. Just difference is 675 plus 9. Next is 9.2 times 10 to the minus 3. Integration t dt. Integration t dt. Yes. Let us say again once more. This gentleman will tell. Integration t dt. Integration. Sure. Integration t to the power minus t dt. No one else will answer. Integration t to the power minus 2 dt. I'll do. Follow. I'll do soon. The first is t dt, correct? T square by 2, half t square. So what it is? Times half. T square means 973 square minus 298 square. Happy? You happy to all set quickly? Well, let us copy down. Plus last term minus 115.6 times 10 to the power 5. Let me know. I'll stop. Actually, quickly. Let me finish this. Maybe next problem, last problem next day. Quickly. I will copy down. T to the power integration t to the power minus t dt is 1 by t minus 1 by t. Hey, you are coming here, big yawn. Oh, so sorry, sir. So sorry. So once in the room, no problem. I'm now included. I'm in shelter. So I'm at par with others. So let us yawn. When you cannot do anything else, you can give a loud yawn. बहुत अच्छा लगता है. So 1 by t minus 1 by this minus will be absorbed with plus 1 by t is 1973 minus 1298. Happy? Okay, okay. So we continue. 37 by 2. I'll keep the only answer finally. Is what for your calculation you can do yourself. This you copy. 80 do yourself. Do the whole problem yourself going back home, and just you suppress this class proceedings and do yourself. Take the problem only. That is a good idea. 8595 plus 3946 minus 3631. Quickly, very quickly. Very quickly, step 1. His answer is 1. I'm writing 149. Write this final. Step 1 final 6835 joule. Did anyone do this? So I am writing here delta H2. Delta H2 quickly. Delta H2. Tell me. Let's see the delta H2. Delta H2 is what type of thing? Chemical reaction. That means this delta H is what then? Delta H is what? Q is Q. We have already sidestep Q. Q to delta H is an achievement. So why you actually regressing? T what you are saying. So don't any answer will not do. Delta H is heat of reaction. Any heat of reaction can be written in terms of formation. Because you want to find though. So you will ask yourself, so how can I find? Oh, this is reaction, heat of reaction. Oh, formation, this gentleman formation. So these two data. But why shall I get data? Our problem is equipped with some data. Data is given to you. So this is the trick. Okay, delta H2 is what? Tell me. See the problem. Reaction 37 by 2. What? Delta H0, delta H alumina. What temperature? 973. You follow this. Okay, quickly. What is this? 2 is where? Plus, minus, delta H, Cr2O3, what is this? Solid, okay, what temperature? 976. Do you have anything else? Delta H0 you can give. Okay. Solid you can write. Okay, it's okay. See, why? Follow the reaction, follow the second step, go along. Formation is what? This is a compound. Will you consider this? Left hand side consider this only. So that I have done. 37 by being common. So you substitute the values of what I am doing for you. So I could have. So 37 by 2. This is how much I am writing for you. This is what I am writing. Minus 1. Take the data. Data I wrote you. I gave you the data. 1676. 000. Since I have already minus 1 to 0. Huge electrothermic. These are okay. These are this. Then if I do this, apply this, what you will get? Second step you will get minus. Write nicely. Minus 10280. Check my calculation. So two step down. Delta is 3. Let us try. Delta is 3. Do take the third step. It is simply alumina alone. Heating. So what is this? Tell me. Delta is 3. You tell me. Delta is 3. This is the first two is over. Third step is what? (37 by 2). Try again. It's okay. 0. 37 by 2. See what type of. See, if you talk around and how will you concentrate? It's a matter of concentration. You are talking. Therefore, what shall I do? Yeah, Anurag, what shall I do?
37 by 2 CP
CPDT, heating, sir. So you have your tongue has not practiced here NCPDT. Why you will practice? You are not preparing. NCPDT heating, sir. Pure heating of one good stuff, namely what stuff it is? It is what stuff? Alumina. Third step is about alumina. CP alumina DT, NCPDT so easily. So 37 by 2 integration CP alumina. What is this? CP alumina is like this. CP alumina DT. What temperature to what temperature? 973 to 1273. What is this? 973 to 1273. What is this? You know CP alumina is given to you. What it is? CP alumina that okay already given to you. Okay, CP alumina. So shall I write once more? I am writing for you. 37 by 2 integration. Okay. 106 point. You check this. 106.6. CP alumina plus 17.8 10 to the minus 3 T. You know CP alumina third step. Wrong. Third step is what? I have considered alumina. I have written alumina third step. Since I have written this, I have written okay. And this is okay. Plus 17.8 plus 10 to the minus 3 T minus 28.5 10 to the 5 T to the minus T dt. Okay, you check this. Data is given, you once more check 970 through 1273. You do yourself. It is alumina, na? Delta is 3. Sorry, I have written this at the beginning. Okay, very good, very good. Then, then what it is? I am giving this value. You can check 37 by 2 is 4 step actually. 31980. Write yourself. Find yourself. 31980. Let me write. Then next is what? Similarly, T integration T means T square by 2. Again, similarly, 5997 minus 690. If you do yourself, 690. See, you said something, whose name is Anurag. You said actually not very bad, not saying very unfair. See, this is the outcome of the first term. Second term 10 to the 5, but there is a 1 by t square. Temperature is going to square at the denominator. So that's why 10 to the 5 actually effectively contribution 690. Second term contribution, which is TDT. But TDT, but coefficient is very awfully small. What is this? See, awfully. See the coefficient? T square though, but it is 10 to minus 3 there. So second term contribution, first term. Well, better. 31,000. So you see, have an idea. So what it is 6 9. You write this. You write this 6. 6 8 6 8 9 9 1 0. So 3 data is generated, 2 remaining. Quickly, can I remove this? This is unnecessary now. Can I write here delta H4? Star it here, double star maybe, double star. Oh, sorry, starring. Double star is where? Shall I remove the top line? Can I? Easily, na? Easily. Fourth, delta H4 quickly. Double star. Delta H4 quickly, since you have started. Fourth is here. Tell me, 37. Is this 37 chromium heating? Cp chromium dt. What temperature? Tell me same way. 973 to 1273. What is Cp chromium? Is write once more. 37 times. Okay. So I am writing this side. Okay. Cp chromium is what? Cp chromium quickly. 24.4 check. 24.4 plus 9.87. 10 to the minus 3t. Minus 28.5. 10 to the 5. 9.87, then 20, 9.87, then 3.7. Thank you so much. Thank you so much. Into minus. There is a 5, t to the minus 2. T power minus 2 dt. Temperature moving from 973 to, and you know you can integrate and all these things. The result is coming as, I'm giving you, the result I'm writing here for you. First is 37 times quickly, 7320 plus 3325 minus 90. Minus 90. Okay, happy? So answer is right here, 3903. 390535. 390535 Joule. Last one is what? Delta H5. Very crucial one is what? Can I remove this? Last one. Remove all these things. Last one only. Keep return last one. Tell me. Sumanto, will you? Yeah. What is this? Amartya, will you tell me? Help me. Last one. Delta H5. Moles. That is the moles. N minus 37 by 2. Right. Times quickly. Cp of whose? Cr23 and dt. What is the temperature? Yes. This time temperature is 298 to final is what? 1273. What is this? I'm giving you, you do this, I'm not substituting, do this part I'm giving you the answer, n minus, you do yourself, substitute, Cp chromium is what? Achha, why? This actually is almost, so I just take, since I've taken already so much time, that integration of Cp chromium I'm writing for you, already once written, so you write here, Cp chromium here written, 119.4 plus 9.2 times 10 to the minus 3 T, right, minus 15.6 10 to the 5. See, first step I wrote 10 to the 5 T to the minus T dt. Sorry, happy? From temperature moving from 298 to 1273. Check this. Check this. You have to write. So answer is this. Write this. 100. This term by term answers. Okay, result 116 415. Second term 7046. Third term minus 4009. That's it. Further, this is what? N minus 37 by 2. What is this result? N minus 37 by 2. What result? 119452. 119452. You want to get in? You want to get in? Come in. Okay, come in. 119. Okay. 452. Joule. Okay. Now quickly. All 5 known. So 0 is what? Follow. Now follow. Now delta is now follow this line. Now 0. I'm writing it. Follow 0 first. Top line. 0 is the delta H1 is overall. Delta H1 is I'm almost close. Overall is what? Sum of this 5. So good. Right. You are following now. Looks like you are following. Body language. Plus delta H2 plus delta H3 plus delta H4 plus delta H5. Good boy. All over. All set. If you do this, then obviously, or see 0, or I'm writing for you delta H1 plus delta H2. This is delta H5 is left hand side. Is delta H5 is what? Sorry, delta which contains n minus 30. N is unknown. N is left hand side. So this is left hand side. That's it. These are going to the other side. So minus delta H1. Tidy up plus delta H3. Plus delta H4, that's it. So last line, last two lines. What is the delta H5 is what, right? N minus, sorry, yes, giving there. N minus 37 by 2, 119452 is minus 1 by 1. Tell me, delta H1, tell me from here, result give me. What is it? This one, no? Underline, this is delta H1. Delta H2 underline. What is the result? Good boy. Thank you. Here. And third is this. So write this. So I'm writing for you. 116. What is that? What is this? Is what? Minus, tell me. Minus what? Tell me what are the figures? Achha, right. Minus 149. Good boy. 149. 6835. Please check quickly. It is done. Minus. Okay. Minus. Then what is minus delta H2 is what? Plus. This is plus. The minus is here. Minus and plus. Plus is what? You do yourself. Okay? 10 unnecessary. 1028 450. And 2 more. I'm removing this. Okay? Delta H2. Delta H3 is what? A moment ago I have removed this. Minus. Delta H3 is what? Minus. Oh, this is 3. Is this one, no? 689. 689. Tell me. 810. 689 810. Is okay? 98 have written. Is it 99 or 98? 99. Sorry, you check this, huh? 99 should be 98. 99. Huh? Minus next is what? 390535. It's okay, it's okay. What's problem? Tell me. What's your problem? Tell me, tell me. Tell me. First, this one. It's 10880. 84. Oh, thank you, thank you. Very good, very good. Oh, you have good eyes. Thank you, thank you. So what it is, quickly, is what I am giving the result. The result is all these things, 770, right, rise. 770, 3270. Good boy, good boy. Then N is what? Or N is what? I'll put a double star, triple star, I don't know, triple star. Triple star, because this is the concluding line, remove this. Concluding line, triple star is, N is what? N is what? You do the calculation? Yes, yes, yes. Oh, you have done this? Just now? Just now? Good, good, very good. Moles? N is key. Moles of? Who? I've forgotten. A long time ago, Cr23 solid. Okay, this is the answer. So many moles, but you ask how many kg. So no problem. Mole means gram mole to gram or gram. Gram is what? Into molecular weight. 52 into 2, 104, and 16 into 3, 48, 152. Right this way. Gram and kg. If you want to convert into kg because it is too large, divided by 1000 kilogram, and that's it. What is the answer? Answer, have you got 12.6 kg chromium. Answer. Thank you so much. Let us stop here. Time, go on. এই প্রভাবু এসে দাঁড়িয়ে আছে বলে নাকি প্রভা হয়ে গেছে সরি চল 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 হ্যাঁ ও বোধহয় এসে গেছে